So this short video is going to explain the conservation of charge intuitively. Now, the conservation of charge law tells us that charge cannot magically appear or disappear. It can only physically move from one region to another. The continuity equation simply expresses this in maths, in terms of maths. So let's say, let's imagine a very small volume in space. Say we'll take a tiny cube, for example, a very small cube. Inside this cube, we place a single electron is a single charge. If this electron moves out of the cube, the amount of charge inside the cube decreases. We can already see something. The outward movement of charge is directly related to the rate it leaves this volume. Let's extend this idea. Suppose now we place two electrons. Suppose now we place two electrons inside the cube instead of just electron leaves the volume, which decreases at the same rate as before. Now, if both electrons leave the volume simultaneously in any given direction, it doesn't have to be on the same surface, it could be in any direction, as long as it leaves the volume of the cube simultaneously. If electrons leave, the rate at which charge leaves, volume doubles. So the greater the outward flow of charge, the greater the rate of the volume. Understand? Mathematically, this outward divergence density. Current density tells us how much charge is flowing through a unit area. Divergence measures the net from a region. This leads directly to the continuity equation. The divergence of density equal to negative rate of decrease. Just say the rate of decrease, the rate of unit volume. The reason why it's negative is because charge is leaving this volume, and so it's reducing. Negative sign is polarity. Tell you the direction it's leaving. Charge flows outward from a region, then the amount of charge remaining inside that region must decrease. A simple way to visualize this is with an analogy, and that analogy is with a water balloon. Let's get a water balloon, fill it up with water completely. We puncture the balloon with a needle. You would imagine that water would rise. There's so much amount of water inside the balloon initially. Less water remains inside, the decreases. You can imagine emptied 80% of. You can imagine that the outward flow, the divergence, even though divergence, you get the idea. The divergence more water in the balloon to. And so yes, as less water remains inside, the outward decreases. The flow of water is related to changes. The continuity equation is charge